What is the value of experiment in scientific study? Explain with some examples. This is a question from Sangeeta BK via Quora.com. Very interesting question because we can learn a lot of why people do experiments, fundamental stuff. Experiments, they provide us with data and observational proof of, so that we can accept or reject a hypothesis, accept or, refute a theory. You understand? So like when Galileo did his gravity experiments, he was leading us on the path to Einstein's relativity. Then when Newton, he did experiments. When Newton did his experiments with light, we understood that light could be split up into many different, wavelengths, different colors, and Einstein's relativity using light and clocks. Clocks actually slow down, due to gravity and speed up. And that's why it would be simple to prove whether gravity is a particle or not, given it is a wave. Anyhow, and my experiments proving that everything must be discrete and can be isolated. So I had to test magnetism to show this. Experiments with entanglement to prove, Campbell's theorems equally, be broken and stuff like that. That's what experiments are for. And they should be easily reproduced, My experiments, even a grade 5 can do them, They're that simple. It's the thought behind them, but the experiments themselves should be pretty simple, The thing with light, wave thing, pretty simple, reproducible. The double slit experiment, where my kid did it when she was in grade 4. I wonder if she still remembers or still cares, but she did it. Because I was so mystified by it. I wanted my kid to know it. And then experiments also, they provide a controlled environment. Here we're looking at two things. Let's say we're looking. This is my daughter's stuff. These two things. So in an experiment, if we're isolating them, we can then know the energy relationships between them, you understand? Because we've isolated what we can, And when we look, let's say we look at this alone, we can see how is it behaving alone. And then when we see this, what type of energy is putting it together, and then we quantify the relation, those energies, we quantify them, give them names, joules, volts, kilograms per square inch, something like that. You quantify the energy relationships, you got to quantify them. So that's the idea, that it's controlled, And then, as I said, I did an experiment for I showed my daughter the double slit experiment, which inspired me too, which helped me out when I was pretty stuck on how I'm going to test magnetism. We don't get grants. That's just the way it tipped out, and many people do get grants for big physics things. They fail, and that's how it is. So they're good for education. That's why schools with labs are important. You like chemistry, put test tubes in there, your kid mixes things up, they blow up. And a kid will appreciate the science more rather than them telling them, oh, if you mix this and this, it will blow up. No, let the kids mix it. Oh, it turns green instead of, it's for education purpose, so that people appreciate the science more. And, and experiment stuff like that. The technology we have right now, us communicating, having this relationship over our phones, this is stuff that started the, the idea of the technology, you can say, started with Newton splitting up that light, the idea of it. Well, not the idea, the basic principles of it. But through experimentations, here we are with an internet. So that's what they do. That's how important it is to have a culture that respects knowledge. You respecting everybody's knowledge, Well, if obviously they do not like that kind of culture. That's why you take somebody else's mind. But that's why ideally you want that kind of culture so that everybody can participate. And see, it took that long because there wasn't that much people studying science, in Newton's days. Maybe there weren't that many, so now there's so many, and the more the better. But we can say this technology, and when we look at car engines, how they work, it's through innovation, through people understanding heat and thermodynamics and metals and materials, understanding them better. And sadly for me, we're still waiting for graphene. I thought it would take over the whole world. Well, it was an opinion. Maybe its time will come. And a last point about experiments is that they lead to problem solving. You do an experiment and then there's a problem here. Take people looking at the James Webb telescope. They're looking for, they say, oh, there's a problem with our previous models. The James Webb telescope is exposing weaknesses in those models. This is because of an experiment. And, and another example, in 2021, I published my papers on magnetism with the experiments that I've done. And I showed weaknesses in the standard model. It wasn't fashionable to talk about weaknesses in the standard model, But now it is fashionable to talk about weaknesses in the standard model. Whenever you go to a scientific magazine on the internet these days, oh, so-and-so did an experiment, showing weaknesses in the standard model. Oh, it's all nice stuff. But it's not as dramatic as showing that the stuff coming out of here is not voodoo. It's not the Holy Spirit. It is something discrete like everything else. That is dramatic. But still, this is how the modern society is. So they bring about problems, and these problems need to be solved. So there's weaknesses. I showed there's weaknesses in the standard model, fundamental weaknesses. It's not incorporating a whole class of particles. Anyhow, we'll talk later. That is why Mr. Sangita or Miss Sangita that is the value of experiments in scientific studies, and I hope I've given you good examples. Have a great day, and thanks for the question. It was nice and relaxing to answer.